Okay, so for the following, we have to solve for I. Okay, so the first thing we can see is that if I can add all of these impedance values up, then I can, divide the voltage value over the impedance value to get I. So let's try and see what we can do. So we already see, if you were to try and find the impedance equivalent of this, you're gonna notice how difficult it's gonna be. Like, what am I supposed to do here? Like, what's in parallel and what's in series? So what I'm gonna do is do this. So I'm gonna take this portion of our circuit. Okay, so this part's connected to something, this part's connected to something, this part's connected to something. There, over here. Now, first let me combine these two together. So it'll be 8 plus 5j. This is 4j, and this is minus 3j. So I'm gonna try. So this is, notice how it's in a triangle. I want it to look like a Y. So I want it to look something like this. Okay, this is the triangle to Y transformation. So this one, let's call it Z1. This one, let's call it Z2, and this one, let's call it Z3. All right. So for Z1, it'll be equal to all of the impedance values. So 4j minus 3j plus 8 plus 5j. Sorry, like the bottom part, the denominator will be all of the impedance values summed up. And the top part is the tricky part. So we look here, let's follow directly below it, and we see we reach the 8 plus 5j impedance. So we're just going to ignore that completely and just times these two together. So it'll be 4j minus 3j. Okay, and solving them manually or using a calculator, we're going to get the following. So just give me a sec as I try and figure what the value should be. Alright, so I get the following: 0.86 minus 0.72j. So that's the value for Z1. Now for Z2, it's the same principle. On the bottom, so this is 4j minus 3j, which is 1j, plus 8 plus 5j, 5j plus 1j, that's just 6j. Alright, so the sum of all the impedance values. Then let's find what the top should be. So we see as we go along this direction, we hit this minus 3j, so that means we'll ignore it. So it'll be 8 plus 5j times 4j, and then summing, adding every, putting all of this to your calculator or finding it out individually yourself. Let's see what I get. So hold on, just give me a quick second. Alright, so I get 0.32 plus 3.76j. Now for the last part, Z3, again, bottom 6j plus 8. The top, as I go along this direction, I hit the 4j, so I'll ignore that. So minus 3j times 8 plus 5j. So let me see what that will be equal to. Alright, so that's what my Z3 is going to be. So let me redraw the circuit, but include the Y, include this portion instead by replacing this. So yeah, okay. So this part, that's, what was it, 0.96 minus 0.72J. This part was, what was it, 0.32 plus 3.76J. And then this part, it was minus 0.24 minus 2.82J. Now, unfortunately, we have to do the same thing all over again, but for this portion. Okay, we have to transform that into a y. So let me write it here. Okay, so this is 8 ohms. This is 5J. What else? Oh wait, hold on. Wait, never mind. I think I made a mistake. Sorry. It should look like this. Sorry, I included this part. That was my mistake. Sorry, it should look like this instead. Because this y thing, sorry, this portion is supposed to represent this portion, and obviously, if you guys saw, I re-added this portion again down here. I was not supposed to do that. My apologies. So yeah, this is the proper way. Okay, then that's a lot more better. So this is 10, this is 5, and this is minus 2J. I can combine these two, so it'll be 5 minus 2J. Okay, this 10, and this one is okay, but I'm just going to put this as a square box because everything else is a square box here. Alright, so notice that these two are in series, so you can add them up, and then same with these two, they're also in series. So I'm going to write a new circuit here to show that. And I'm going to write it in white. So 0.32 plus 5, that's 5.32. Then 3.76 minus 2, that's 1.76J. Okay. Then for this portion, minus 0.24 plus 10, that's 9.76 minus 2.82J. Now these two, they're in parallel, so it'll be 1 over 5.32 plus 1.76J plus 1 over 9.76 minus 2.82J, all to the power of minus 1. So let me see what that gives me. So I get the following: 3.743 plus 0.4074J. Okay, so I can just rewrite the circuit like this. And then I can just combine these two together. So 0.96 plus 3.743, that's 4.703. Then minus 0.72 plus 0.4074, that's minus 0.3126J. So I'll just write that like this. Alright. And then recall there's a current passing through here. And then this source, it was 30, phasor 0. Alright. So let me get the real and imaginary numbers from here. So it'll be 30 cos 0 plus j 30 sine 0. This is just 30, this is 0. So we'll just represent the source as just 30 volts. Now we know V is equal to I times the impedance. So V over impedance, that's 30 over 4.703 minus 0.3126J. So let's see what that gives me. So 30 divided by 4.703 minus 0.3126J, that's 6.3508 plus 0.42213J. Let's get the magnitude of this. Square root it all. So let me see what this is going to be equal to. So that the magnitude will be 6.3648, and let's get the degree. So tan inverse the imaginary part, which is 0.42213, all over 6.3508. So let's see what the degree is. It's 3.803 degrees. Alright, and that's your I value. So I is equal to this much amps.